We're good? Can you guys hear me? Yeah? Great. All right. Well, welcome. Thank you for coming. Today, we're going to be talking about the next generation of the modern data stack and what that means for essentially unlocking ROI of a data team and all the things data teams are doing and the business value that they're providing. So, firstly, a little bit about me. I started as a data analytics consultant in the services world. Have seen a bunch of different types of end-to-end data projects, different organizations, different data stacks, skill sets of data teams, and I think this is really where I felt the pain of being on kind of the data practitioner side of things and kind of proving your worth, right? Or seeing like, okay, all of this technology that we're combining to do these things, that this actually is moving the needle in terms of what we're doing for our organization. About 4 years ago, I joined RIVERY. I was the first solution engineer when we were a very small company. This role was kind of a dual role, had some duality to it in terms of I was also managing our internal data stack. So not only was I kind of doing the data practitioner things, but I was also helping to sell our product. And really these kind of first phases were, I think, where I got most of my empathy for data teams. Now I lead our solutions engineering practice, so solution architecture across our customers and prospective customers. So quickly about RIVERY, the company, we were founded a little over 4 years ago. The product itself has been around a couple years longer than that. It was kind of started as a bootstrap project inside of a services company, and then eventually we separated it to kind of go the true startup route. Now it's, we have customers globally, offices in London, Tel Aviv, and New York. And so I guess to kick it off with the actual topic itself, I want to start kind of and level set the stage for, we're talking about modern data stack and, what is the next generation of that. So first let's talk about how we got to where we are now. And I think really in terms of the modern data stack, the kind of creation and evolution of it started about 5-ish years ago, I'd say. Now, obviously data has been in the cloud longer than just 5 years ago, but this is really when I think data workloads started, the growth of them in the cloud started to accelerate. And I think largely it's because of this like gravity effect of wherever our data is sitting is where we tend to bring the tech or bring the compute. And so with kind of the rise of the cloud and SaaS applications and data being stored natively or by default in the cloud, the next natural thing is that functionality or technology that is kind of our compute or managing our workloads would then exist in the cloud. Also with that, what that led to is because we now can store and compute in the cloud, led to this shift from kind of our traditional ETL approach to ELT, or loading data there first, and then transforming or computing, operating on the data as it lies there. I think an opinion of mine, maybe a biased one, is that I think kind of these revolutionary technologies such as Snowflake was a huge driver of the modern data stack. I think Snowflake came to the market with something very different, which was separating storage and compute and being able to auto-scale up and down and only charge you for what you're using, so the pay-per-use model. And they had an easy self-service way to do it. It had a very nice user experience. And so these kind of attributes, I believe, are what other products in adjacent data markets tried to replicate. And that ultimately became a stack of things. And really, the modern data stack is, the nucleus of it still is like the data warehouse or lakehouse. So you have products that are ingesting data to get data in. You have products that are transforming data, orchestrating these processes once the data is in the warehouse, and then also the products that are helping you visualize, gain insights, or even send data back to source applications. So to continue with kind of a more visual view of what is the modern data stack, this is kind of the common technologies. When we hear modern data stack, what we think and what we see in a lot of kind of common stacks across organizations. And really the value of this is kind of the attributes that I mentioned in terms of kind of what Snowflake and similar tools brought to light, I'd say like maybe 5-8-ish years ago, where naturally they are cloud-based, so many of which are SaaS tools or at least cloud native, easy to use in terms of for whoever their audience is, easy to use. So sometimes being low code, no code, sometimes being a code first approach, but kind of adhering to the audience of that specific data functionality. Again, a consumption-based model tends to be a commonality here for a lot of these tools. It's just kind of saying pay for exactly what you use, so that barrier to entry in terms of cost is much lower. So if I am any sort of business, I can at least test this out, try out these technologies without much like upfront cost. And lastly, they tend to speak the same language. So a lot of these products kind of leverage SQL push-down transformations in our data warehouse. SQL is something that I don't think is going anywhere anytime soon. So even our kind of low-code, no-code tools are kind of building components right on top around SQL. So naturally, and what I'll dig into more today is, we've seen this rise of the modern data stack, and there's a lot of advantages to it over the last few years. But there are these like natural shortcomings when it comes to like, this kind of chained link approach of technology. So first, what we coined here, integration hell. And by integration, I don't necessarily mean integrating with like all of your sources. I mean integrating all the pieces of your stack together so that they work seamlessly together, and you can orchestrate all your processes, have full visibility over the stack. Secondly, bottleneck prone. So kind of a stack in just its in any sense of a stack is you're linking things together in a very linear way, right? So there's like upstream processes that happen and that needs to happen in order for downstream processes to happen. And so naturally this is very bottleneck prone. So if one link in my chain fails, then nothing downstream is updated, and ultimately I'm not delivering business value, in a time efficient manner. And lastly, I think big challenges with scale. So scale when it comes to scaling up, so larger workloads or higher velocity of workloads, and then also scaling out, so a different variety of use cases across different teams. I think what's great about the data market today and companies today is we're finally realizing that data is a first-class citizen, but also what that means is there's like more and more demand for data from the business. So not just our traditional BI use cases where I need static reports or dashboards. Now I want data back in my operational systems, or I want data so that I can run ML models. So there's different variety of uses now more than ever than there was kind of when the modern data stack came to be. So firstly, digging into all these shortcomings, integration hell. And this is like just a very, an example of what a modern data stack implementation might look like. Now, all of these products are like excellent in their own right? Like best of breed products in terms of the different areas of the data stack, right? But where it gets a little convoluted is when, and this again is just kind of the basics maybe of a stack. You still have a data warehouse as well. You might have observability over the top, a BI tool, et cetera. So the question becomes like, what is the cost of like integrating yet another tool into my stack? And does that tool give me some measurable benefit in business value, right? So we have all these tools here. And again, yes, so mind the gap in between technologies was the thinking here. In terms of consumption models and like pricing models as well, like every single product transparently is trying to make a margin, right? Trying to make money and be a successful company. And so when it comes to you as like the buyer, you now have to understand all of these different pricing models, how to optimize each one. But then when all these pieces are working together and required to work together, how does, maybe some more data flowing through my ingestion tool, what does that mean for consumption in all of my other tools? So not only do I have to optimize them separately, but also how it works as an entire stack in my organization in terms of when things scale or when new use cases arise. How can I gain economies of scale with the actual costs I'm paying to vendors, let alone resources that I'm paying for. When we're talking about resources and people, these tools as well have ease of use and self-service nature for their specific audiences, right? So for getting data from any source, having a pre-built connector is amazing. I can just click a few times, get data dumped into my warehouse. But then if I want to do transformations, I now have where, SQL as code is the approach. So I'm constantly context switching from something maybe like no code, low code to something very code forward, right? Which can take time and build friction into the process here. Secondly, bottleneck prone. So we have here a visual of a bottleneck, but basically the idea is that with technology is kind of all linked together in a linear chain, it's very natural that there are pressure points, right? That a lot of compute or a lot of manpower are needed in order to serve insights wider to the business. So what that could mean is not only technology-wise are there bottlenecks that can be created, but people-wise and knowledge-wise too. If we have kind of one team that's centrally managing this whole stack, if something goes wrong, there's only kind of one place where we can get that knowledge rather than it being kind of decentralized throughout. And next, scale challenges. So this is kind of a visual of two, different levels or types of scale, I'll say. So let's imagine that we're implementing a stack and we have a few different data sources, our first use case. And then basically we want to add more data sources to that so that we can enrich our data models and provide more insight and value back to the business. And those data models are also evolving. Maybe some of the sources we don't necessarily have control over, and there's new fields, schema changes, et cetera. So how does our stack match those demands, and how is it flexible? And then kind of this next level of scale, which is we need to serve more than just one team or just more than just the team that kind of we first built our use case for. We have different types of use cases across AI and ML, or pushing data back out, doing some sort of data activation. And again, what no data team wants to do is become a services org where just the tickets, the pile of requests just stacks up, and they're just kind of drowning in requests in terms of scale. And so having that kind of modern data stack technology doesn't lend well to things scaling quickly. And this is, yes, again, so as time to deliver gets longer because we have more requests and more types of use cases, naturally cost increases, not just costs of our licensing models of the actual tech, but the people themselves and people that are operating at reduced efficiency because of lack of visibility across all the different products that they've implemented in their stack. All right, so now time for the pitch part. So we went through all of the shortcomings of the modern data stack, right? And one thing I want to note before getting into hello modern data platform is there's no one answer to how you should set up a data stack. I think every organization has different needs and different things work for them. What I'm mostly trying to say in the next few slides is I think there is a way to be better. I think there is a way to incrementally get better than just what we know is the modern data stack and how to do things. Not saying this will solve every company's problems, absolutely not. But I think there's a different way of thinking about it rather than let me piece together these tools in a linear fashion to eventually deliver data sets or data products to the business. So, what is a modern data platform? What could that look like? Obviously, I'm very biased in terms of what that could look like. But in terms of kind of all these different pieces of the stack, acting together, working together, speaking the same language, it makes sense to kind of have this all available to users in one place. So being able to ingest data from any source, whether that's a database, API, file replication, et cetera, and then conduct downstream transformations and be able to send data back out to source applications, leveraging something like reverse ETL, and also being able to orchestrate this all together so these flows are seamlessly interlinked. You'll notice here for transformation, for example, there's some other logos of other products here, and the idea is that yes, with a platform, everything's happening in the same place, but it's also flexible and easy to integrate with other tools. So if there are pieces of the stack or platform that you want to leverage, then that is very possible and easy to do. So the idea is for each organization, creating your own best of both worlds depending on what your data needs are. So we talked about what a platform is and how that relates to the modern data stack in terms of kind of having those same principles. You might be asking, well, what's the difference? We had data platforms in the past, right? So before kind of the rise of the modern data stack and the cloud, there were these legacy data platforms. So what's the difference there? And I think really it's those core principles of the modern data stack that it brought to light is that there's, it's cloud native. There's no infrastructure or very little infrastructure to manage. It's very easy to connect to our data. There's an API first approach in terms of pricing. It's pay per use and easy to predict, etc. So what is the actual value? When we're talking about business value, what could that actually mean? And what are the examples of value we might get? So first, faster time to value. So there's fewer tools to manage, fewer tools to set up. In terms of piecing together different parts of your stack, it's all in one central place, and then also reducing that context switching between different skill sets. It's all speaking the same language in terms of everything from end to end. And what added advantages you get when you can do something kind of unified end to end is that when you're thinking about templatizing or reusing pipelines, this can actually be all the way across your pipeline management. So starting with the sources to maybe the transformations that you're running and the data modeling that you're doing, and then kind of automating that, you can easily replicate an entire use case rather than just pieces of a use case. Now let's talk about costs. Now again, this is very much just an example in terms of an example use case. So let's imagine you have many sources here. We took some information from a case study of one of our customers that had about 20 data sources, and what they what information they would give us about what they were paying beforehand in terms of different ingestion, transformation, orchestration, tooling, and comparing that to just kind of having to worry about one commercial model and one piece of tooling or platform, and then adding on what an FTE cost or team of resources might cost to deliver and to bring value, on top of just the tech, right? There's other costs at play for, let's say salaries of these skilled people, as well as how efficient they can be with what they're working on. So here's just some examples of kind of some value that was gained by RIVERY customers in terms of reusing data pipelines, saving time, saving money in terms of getting production ready, scalable very quickly. So in terms of what's next for data architecture, and I have only a couple slides left, I want to again preface that I don't think there's any one answer, and I don't necessarily think any one product can fully cover every need, especially enterprise needs of pipelines. But I think the kind of mindset of just implementing the modern data stack needs to shift. And I think what that means is I saw a really what this is from, and this link here is from a very good article by this guy Timo, and what he coined in that article was in terms of what's next for data infrastructure, it's having platforms that are closed but open, right? So taking the advantages of something that is centralized and leveraging things that are important to centralize, like user management and being able to reap the benefits of having everything in one place, but also being open enough and flexible enough to integrate with other best-of-breed products for specific needs that might come up that you need to like completely customize for a use case. So this idea of closed but open in the future. And then lastly, what's next for data architecture? Again, on like the centralized point, I think there are a lot of recent revelations when we think about concepts like data mesh, like paradigm shifts, right? And I'm not going to say like data mesh is the answer for every organization. I don't think it is. But I think what data leaders should be asking themselves are like, what pieces of my operation, of my infrastructure should be decentralized, and what make more sense to centralize? We think about things that should be uniform throughout, like governance, security, compliance, having role-based access control, having like visibility over all the consumption, all the things that are happening. To me, is something that makes sense to centralize and have this kind of governing admin, data office team, so to speak. But then what parts should be decentralized? What parts should domain teams or data product teams self-serve, right? Like if I can give a data product team an area where they can work, where they have governed connections, governed sources, and they can build pipelines themselves, that alleviates a little bit the bottleneck proneness that we were talking about earlier. So I think it's, for each organization, finding where on that scale makes sense in terms of what should be more decentralized, what should be centralized. And yeah, that's it. That's all I have for today.